Greeting ladies and gentlemen, today's video I'm gonna explain about the saturated water temperature table, saturated water pressure table, the compressed liquid and the superheated. So for the saturated water, there is a three state the fluid were in. The first one, there will be saturated, the compressed liquid. The second one will be in the form of saturated, and the third one, it is the form of superheated. So for the table A4 and A5, it is the table for saturated temperature and pressure. For the table A6, there will be the table for superheated water, and A7 will be for compressed liquid. So in this table, there is a pure property that you need to know, which is we have a specific volume, we have internal energy, enthalpy and entropy. All of it were in the form of specific because it is per kg. As you can see, the internal energy, the unit will be kilojoule, but in here there will be per kg. That's why I'm calling it as a specific, in the form of specific. It is in the form of specific energy, internal energy, and it is enthalpy in the form of specific, entropy in the form of specific, because it's per kg. So we'll have in this table we have a temperature in the form of degree C, we have a saturated pressure in the form of kPa, and we have a saturated liquid being denoted as Vf. F, it is for fluid, and Vg, G, it is for gas, so saturated vapor, Vg. There is a Uf, Ufg is nothing except this value were minus by this value, 2374.9 minus by 0.0, thus you will get 2374.9. For example, if you using your calculator, you can prove it that the 2381.8 minus by 21.019, you will get the UFG, which is 2360.8. So that is for the saturated water temperature table. If we go to the A5 table, it is just the same thing, but for the first row, it will be the pressure. Just now, there will be in the form of temperature, but this time, the first column, the first row, there will be in the form of pressure. So it have a same pure property, which is specific volume, internal energy, enthalpy, and entropy, and have a same symbol to express it. The unit for temperature yet in the form of degree C. So we go through to the A6 table. At the A6 table, we have a superheated water. There is a variant of a pressure that we're dealing with. So the lower pressure at this table, there will be 0.01 megapascal in the form of mega. Thus, if you want to convert into kilo, so you need to times it by 10 to the power of 3. So this is the temperature for every single pressure, and this is the table A7. And by the way, the highest pressure for separated water will be A6. That will be 60 megapascal. For compressed liquid water, that will be at the table A7. So at this table, the most lower pressure being set, it is 5 megapascal. If you were lower than that, then you will need to refer to to the saturated table. And the highest pressure will be 50 megapascal. As you can, if you might notice, the saturated pressure was something in between the compressed and superheated. So if you get the substance that have a high pressure, then P separated, then there will be in the form of compressed. If you have a temperature that higher than P separated, then that would be the superheated. It just makes sense to say that when you have a substance in the container, in the confined container, closed system, then you compress it. So it's just logic to say that the gas itself will transform into liquid, because if you were in the molecule form, you didn't have any much space to move. So your distance between your friend will be less. So if you were a gas, because of the pressure will increase, but in the small space, then you will become a liquid. So that is the tips for you, at least it is for me, if I tend to understand when the problem being stated that the P that we were dealing with a higher than P saturated, so which table then I need to refer. So I think that's all for today. Thank you for watching and have a nice day. Bye bye.